Hello and welcome to the next project. In this exciting project, I'm going to do customer segmentation. And as you know, customer segmentation is one of the most important topics in every single company, specifically for marketing team. Customer segmentation can help the managers and the company to focus on those customers based on their need because they have maybe more lifetime value or more benefit for the company. So the data set that we have, it's about a company has some courses, online courses. These courses are for some people working in the data science field. And when the customers goes to that website, they search some courses and after that they need to say why they are using these kind of courses. So it means we are dealing with two kind of data. One is the role of the people visiting the website, and the other one is just a free text. And they are saying, I'm going to use this course because of that. And my role is data scientist, or my role is analytical engineer, or is data engineer. So the company is going to segment these kind of customers based on the reason they are using the website. It means our project is a combination of AI and clustering. It might be a very interesting project, and I'm going to go and show the steps that we are going to do. Okay, before do anything, let me first draw the steps that we are going to start. First of all, we have the raw data. We have the raw data and it is just a two-column data. For example, we have a table, something like that. And this table has two columns. The first column is just the job title, and the second one is just a reason they are going to use the website. It might be a little bit longer. Okay. For example, one user is just saying, I'm using this course because my weakness. That's it. It is just a reason. Oops. It is just a reason. And this is, for example, a data engineer. And so on and so forth. We have so many different information. Just let's say we have, for example, too many similar cases here. This is here. Our dataset contains 66. It means all these sections, the dimension is 66 by 2. It is the dimension of our table. But this is only raw data. How we are going to deal with this kind of problem as a clustering? As you know, for doing the clustering, we need to change the data to the numerical sections because I'm going to use k-mean clustering. And k-mean clustering needs number instead of the text. But this is a text, how we can change it to number. So the next step, if I go scroll down, the next step is data embedding. We need to embed the data. We need to change the data to some kind of number and some kind of dimension. It's not word embedding, it is embedding. It means, for example, if in a text somebody says my weakness, and the other, for example, person says just because I have lack of these skills, in terms of the embedding, they are talking about the same things. So we need to embed the data based on two columns. We have job title, and the next one is reason. I'm going to embed these two columns. First of all, for job title, I'm going to embed for 12 dimension, and for reason, I'm going to embed to 24 dimensions. It means, for example, this case, this job data engineering, this case is going to, after the 12 dimension, it's going to be something like that. For example, let's say we have a dimension like that, just number, it doesn't matter what it is. And this is all of them. Let me just put it there. This is all of them as a 12. All these sections are 12 dimension. We embedded, we changed the data engineering to this kind of vector, and this vector has 12 data elements. And about the reason, the same. For reason, we can just change it, for example, to this kind of embedding. For example, I just copy this one, paste it there, and it is 24. We're going to change all this data frame to this kind of data frame. And it makes sense. The final table is gonna be the dimension. It's not gonna be 66 in two columns. It's gonna be 66 by 12 plus 24, or 66 by 36. This is gonna be the dimension of the table. It means every single row should have 36 columns. All right. After having this kind of data frame, now let me just copy table. This table is after just changing the data. It's gonna be 36. Let's say, for example, vector 1, and remove the rest. Vector 2 to vector 36, just for a case. And each of them is just a number. For example, this is 1, and the other one is, for example, 4, and all the way to the right. This is just one row. It means we change this kind of text after embedding to this kind of number. Now we have a table, and now we can run clustering. For clustering, I'm going to use the k-mean clustering, and I have 5 segments. This company has 5 kind of segments, and they are going to categorize the customers or the users based on these 5 segments. And as you know, the clustering is non-supervised machine learning. It means we don't know which kind of segments we have. And the only thing that we know is how many segments we would like to have. Naming the clusters, naming the segments, it might be anything after running the model, but we know at least how many segments we know. We need 5 segments. And now it's time to cluster. But we are not going to only cluster data. We are going to get the insight and generate the clusters based on the AI, not only the k-mean cluster. Let me explain in detail. Okay, it means if I have this table, let's assume this is a table after clustering. this is a table. We will have one more column as just a cluster label. It means what the k-mean says. It is just a label. Let's call it as a label. This is the label. And this label is gonna be 1 to 5. Let's say, for example, the first one is 1. For the second row, for example, we have 3. For the third row, we have, for example, 2. We have 5. We have 4. And for the rest, we have something. Okay, these are the clusters, and definitely this should be 1 to 5 because we have 5 different segments. Okay, now we have this kind of table after clustering. And now it is ready to generate some information on top of this table. Because if we give this table to managers and said, okay, these users or these row is just in cluster number 1. So what does it mean? What does cluster number 1 mean? What does cluster number 2 mean? So it has nothing to do with the insight or the information, but how we can capture information about these things. It is the place that AI can come and help us. We have data here, am I right? We have all the information here, and these are all the information, all the embedding information that we can take advantage of this kind of information and generate some data. Because all these numbers mean something. And this is what AI can understand. It means we can make what does it mean based on AI and say, okay, cluster number 1, one of them has this one, and the other one has this one. Let's gather all of them as a one, and let's say what does it mean. For example, if first we filter only for segment number 1, let's say for segment number 1, how many records do we have? For example, let's say number of rows is just 12. It means out of all this data that we have, 12 of them label is 1. And each of these 12, if I copy, each of these 12, the label is 1. Label is 1. Label is 1. 1. So on and so forth. All of them are 1. And definitely all of them have embedding. And they have different embeddings. So we can get some information. For example, it might be 3, it might be 6, it might be 2. I just put random number to make difference between each. You see, each of these rows have different embedding. We can pass all this data to AI, and here we can generate some information. And AI can say, okay, what does all this information talking about? What does all of them talking about? And then if I understand what does it mean, I generate something like that. I generate one job title. It means this is one job title, which is a combination, a mixture of all the job title embedded, and one, for example, description or whatever we want. Why they are going to use. Instead of saying each of them one by one individually, we say all together. all these job titles, I, as an AI, can categorize them as something. And after that, based on the reasons, all these 12, what they are talking about. And since they are embedded, it means all of them are pretty similar to each other. This is the process that we are going to do in this project. And first of all, I just explained all the steps to have the better image and big picture about the process and the steps that I'm going to go. Okay, now I'm going to start the process in Python. First of all, I need the data. So let's connect. Now I'm going to import the data that I need. So I don't need this one. This is the code that I'm going to import the data. So I say load data. This is the first step that I'm going to do. Just let me put this one. Okay. Now this is just the loading the data. My data is stored in not unified. This is customer segment, and the title is just a survey, and we need pandas. So one step further, I need to import pandas as PD. This is just a pandas library that we need to have. Let me just put it there, side by side. Okay. And now I can run the data to see how many records do we have. I run it, and we have 83 records as just the default record. Okay, what we need to do is that we need to take a look at the data to know how many null values do we have, because if we have null values, we cannot generate any cluster or any insight by AI. So let me take a look at the data to see how many null values do we have. Just go for df info, and you see we have 74 non-null values. It means we have almost 9 records. All of them are null, and we need to remove those null values. So I remove this cell and say df just drop NA, and then just print the shape. If I run it, and now we have 66. It means we have a bunch of null values, and we remove all the records. They have the null values. Maybe one row has just job title was null, one row only reason, and one row for both. So at the end of the day, we have 66 null values records. Now we can run the just data frame head to see some kind of rows. For example, for job title, we have funder. And that funder just used our website because they would like to fine-tune LLM effectively, so on and so forth. Or we have a staff scientist. They wanted to use our courses because they would like to have better understanding about the skill set of or something like that. Okay, this is the head. This is just the raw data. This is after pre-processing. We didn't have anything. So based on the process that I explained, now it's time to embed this data. We need to convert all this information to numbers. We need to convert the job title into 12 dimensions, and we need to convert reasons in 24 dimensions. So the next step, I say text embedding. This is the next step we are going to do. Here, first of all, I'm going to use the sentence transformer library. I'm going to use all MiniLM L6 version 2. This is just one embedding models just from the Hugging Face. You can use the other one. This is some kind of mini, not a small, not big. It is just a very good model for the number of records that I have. I have just 66, which is fine. But I need to import this kind of libraries because I'm going to use sentence transformer. I need to import this library to my data. So before that, I import a cell and say from sentence transformer as a library, import this package. I just run it. It takes time because sentence transformer library is a very huge library. And that's why I'm using the Google notebook, because it is much faster than my local machine. All right, now it's imported to my notebook. Now I can run this transformer, and I'm going to store as an object, as a model. Now my model is ready. This model, you see all the steps have been done because this is just a ready, it is just a pre-trained transformer. All the steps, tokenizer, even the weighting, safe tensors, all of them are ready to be used for our model. This is the magic of transformer. The model is ready, and now the next step is I'm going to apply this model for my two columns. One column is job title, which is here, and the other column is join reason, which is this column. And both of them, the model is going to apply, and then I'm going to convert it to the numpy. So I need to import numpy here. I just import numpy as, import numpy as np, just in case if we need numpy, we have it. And then I'm going to just embed the job and the reason. I'm going to store them as a job embedding and reason embedding. If I run it, now we need to wait, all embedding is run. Let's take a look at the data, for example, the job embedding. For job embedding, this is all the numbers, even something here are job embedding, and they are vectors we cannot see. And all of them, all this number means funder. Or if I run, for example, for reason embedding, all these numbers, all these vectors means this text, the main context of this text, not one word. It is the main concept. But if you remember at the beginning of the project, I said we need to have 12 job title and 24 reason, but we didn't mention anything, which is right. Here, the number of the lengths for every single vector is coming from the default for this model. And for this specific model, if you just read the documents, the specific number of the dimension for this model is 548, if I'm not mistaken. It means this is 1, 2, 3, blah, 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 and the last one is just 538. But we need the less number of the dimension. We need to truncate. So I remove this one, and now it's time to truncate the number of the dimensions based on the number of the dimensions we would like to have, not only the default or the nature of this model. I just create two objects. One is job embedding dimension, which I put 12, and the reason embedding dimension, which I put 24, and I run it. Now I'm going to modify these find of code. And here I say, okay, the new job embedding is the previous job embedding, but number of the rows, which is fine, it should be at exactly what it is. But for number of the records, let's start from whatever it is, from number 1 until the 12. For the rest, remove it or cap it. This is we would like to have for the embedding, for the job, and the reason. We are just slicing the embedding, because the embedding, as you know, it starts from 1, 2, 3 to the end. The most important is it's just started from number 1. Now if I run it, and then if I go for job embedding, you see, for example, if I scroll up, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. All these numbers mean funder. And as you can see, if I scroll down, all the way down, you see we have for all the 66. All of them are 66. And we can do the same also for reason embedding. But they are two separate embedding. One of them has 12, one of them has 24. But our dataset are all together. It is true. Each of them in terms of the number of the rows, they are 66. But for number of the columns, they are different. So if we concatenate together, at the end of the day, we have 66 rows and 36 records, or number of the columns that I explained at the beginning of the project. So let's concatenate these two together. I create as an embedding list. This is just the final columns. And I use the NumPy concatenation function. It is just say for every single I, for every single records, for job embedding, let's concatenate for the same number of the rows for that reason and just concatenate together. And the length is length of just the data frame. How many records do we have? If I run that, and now this is the final table that we have. We have 66 number of the rows and 36 number of the column. If you just more curious to know number of the columns, you can just stop this video and just count all the number of the columns. They should be 36. All right, now I can remove. We can go for the next step. Okay, but this is not a data frame. This is the list. And we cannot apply the clustering on a list. We should have a data frame. So this is easy. Just convert the list to the data frame. And it said for each job embedding, which is just for the shape number 1, and for the reason, just put all together as the total number of the records that they have, and then just use the embedding list that we created here. And for the embedding list, the columns are these columns name. It means for those columns, they are related to job embedding. They should be started with job embedding. And for those records, they are related to reasons. They should be started with the reason embedding. If I run that, and you can see we have this kind of data frame. We have 66 records, 36 columns. These are the job embedding 1, 2, 3, 4, and they should be till 12. And after that, we have all the way to the right, they are related to reason embedding. Now, for every single row or every single record in our project, we have embedding. Now the data is ready to start the clustering section. And the next step is just making the clusters, making some non-supervised machine learning. For clustering, first of all, I import the library for k-means. And number of the segment is just a 5, as I said, for unsupervised machine learning. We know how many number of the segments that we have, but we don't know the title. I only know I need 5 segments. And I apply k-mean clustering. Number of the clusters is just a 5. The random state is just a 0. It means if the data shuffled, I would like to have the same number. And after that, all these steps should be applied for this data frame that we just created in the last step. If I run it, the clustering is started. Now, if I go there, and now you see clustering is here, and this is just the k-mean clustering model. Okay, we created the clustering, but we have not still applied on to find the labels. It means the model is run, but we didn't get or we didn't ask the model to give us the label. At this moment, I'm not going to get the label because having the label here doesn't matter. For example, for row number 1, which has 36 vectors, we have one more column as a segment 1, segment 2, segment 3, or segment 5, 4, but it doesn't mean anything. We should create the labels, then we would like to pass the label to the AI. So we are going to do in the next steps. So the next step is going to generate some information. And I'm going to separate one step as a prompt. Prompt building. Prompt scenario is very important. I would like to have the separate steps for it. This is my prompt that I'm going to have. I'm going to have this kind of prompt. I would like to say this is just a prompt for AI. I'm going to say you are a business strategist specialist in customer segmentations and profiling. Below is just a survey result for the customers, including the job title, the reason, blah, blah, blah. Please include the job title as your result, just a single representative job title summarizing those listed in the table. It means, for example, for segment 1, if we have 5 or 6 different job titles, just have one word which is just representative for all of them, just as a singular. It means, for example, if for segment number 1 we have 10 or 12 records, each of them might have different job titles. Just give one single representative job title, which is summarizing for all those 12. And the desired outcome is just the reasons why, at the end of the day, altogether they are using these kind of services. And after that, this is just the instruction. Keep each section concise, one sentence for each, just 100 characters, and so on and so forth. This is just a prompt for our model. I'm going to go for the next step with generating with AI. This is the next step that I'm going to apply. First of all, I need to just install the Anthropic on my notebook because I don't have it. So let's start Anthropic. I'm going to use the Anthropic for the cloud. And I didn't use the OpenAI just because I had the API key in the cloud. If you like, you can use the OpenAI. Even if you use the OpenAI API, you don't need to even use the Hugging Face embedding models because OpenAI has the text embedding models itself, unlike the cloud. So the next step is that I have the Anthropic. Now I can create the client, which is just working as a bridge between my notebook and the cloud. Anthropic, we don't need this one, import Anthropic. And Anthropic is ready. And now this is my API key from the Anthropic. Now I'm going to create a client. And if I run it, now I just remove this key because this is just a secret key. Okay, now I pass my key to the Anthropic. Now my client is ready. If I just run the client, this is the client is going to just make a bridge between my notebook and the cloud. To pass the key, I'm going to pass a data frame. This data frame is going to go for the prompt template. And that prompt template is going to be applied on the data frame that I'm going to pass to the model. After that, a response is going to be created based on the client from the cloud. And it's going to be the model as a cloud sonnet. And the token, this is just a number for the temperature, anything. For the temperature, I put 0.5 because I like the model to be a more creative. Not very solid, not too fancy creative, just a middle between 0 and 5. And the message, just for the users, is just whatever it is. And for the content, which is coming from the prompt that I created here. And after that, the customer avatar is gonna be just apply the response on every single content and just return the customer avatar. This is just a function that I defined to apply this kind of process for all the records that I have. It means all the records, model is going to apply all this prompt on top of that. But still something is missing, which is, where is a cluster? Here I'm going to say range from I to number of the segments. If you remember number of the segments, here is 5. From 1 to 5, I create a data frame, which is the survey data. And I pass the data frame, the data frame that we have is just this data frame. This data frame, this is just the data frame. I'm going to say, for those data frame, apply the clustering and the label, which is job title, and join reason. And after that, based on the length of the survey, just create, for example, 1 to 5. And then for this time, pass this survey data as a prompt, and then create that prompt based on my key. Let's run it and see the result. You see, model is start working. For segment 1, we have 12 number of the segments based on a clustering. All of them based on a different job title they have. The AI suggests that they are technical founder or they are product leader. And the main reason they're going to use our platform for the courses, they're going to gain practical or hands-on experience building and fine-tuning LLM model for real-world application, RAG system, and so on and so forth. Segment 2, we have only 4 cases, which I, as a model, can categorize them as a manager or product leader. They are going to use hands-on AI knowledge to understand the technical implementation. Segment 3, we have only 16 records, and they are data scientists and technical professionals, and this is the main reason. For segment 4, we have 27 number of the records. This is the highest number. They are more technologically leader or founder. And this is the main reason. For segment 5, they are some kind of senior software or data engineer. And this is the main reason they are going to use our platform. It means the combination of AI with clustering can make a lot of information instead of just say, okay, this is just segment 1, segment 2, segment 3. So what does those numbers mean? We should generate some insight about those kind of segments, not only say the exploratory data analysis about the segments. In this project, I just wanted to show you how I combine the clustering with AI for customer segmentation. If you would like to download the data and the code, you can use my GitHub link that I put in the description below for this video. I hope you enjoyed this video and thanks for your watching.